Alright, so today we're going to do 6.1, Who Will Win the Last Banana lesson. Okay, so today is actually the first lesson about what's called probability and statistics. So a little different than what we've been doing before, but some of you might find it fun. So let's look at the situation. Suppose that you're on a desert island playing dice with another castaway. The winner's prize will be the last banana. Doesn't sound that fun. How are the rules of the game? Each player rolls a dice. Do you guys know a dice? Hopefully you do. It's 6-sided. 1, 2, 3, 4, 5, 6. Okay. Okay, so one person rolled this dice, another person rolled this dice. If they tie, probably do it again. And then the largest value shown is 1, 2, 3, 4. Then player 1 wins. The largest value shown is 5 or 6, then player 2 wins. So let's look at this example right here. Okay, so the first person rolled 3, second person roll 1. Who's going to win? The 3 is the largest number, right? So the player 1 is going to win. Okay, let's do it again. Let's say that's 2 and that's 5. What's the largest value? 5. That means the player 2 is going to win. So that's how you're going to do it. Okay, what about this? Largest value 6, player 2 is going to win. Largest value 6, player 2 is going to win. You see that? Oops. Largest value 2, who's going to win? The player 1 is going to win. So that's how you're going to play a game. Okay, so who do you think has advantage in the game? Player 1 or player 2? Or neither? Make your best guess and explain your choice. So here's the thing. We're supposed to do this as a class, but apparently I'm not there. So I'm just going to pretend that you all done it with me, and then we're going to answer. So what do you think? Who has a better chance of winning? Player 1, meaning largest value being 1, 2, 3, 4, or player 2, meaning largest value being 5 or 6? It's going to be player A. Why is it going to be a player A? Because there are more numbers to win, right? There's 1, 2, 3, 4, and 5, 6. There are only 2 of them, but there are 4 of them. So there are more numbers to win. Right? Okay, so to play games 20 times with your partner and record the winner of each game by tallying in the table below. So I'm supposed to play with you, but can't, so let's just play together. Ready? I'm going to do it 20 times. Well, you know what? This is boring, so I'm going to pause it, and I'm going to play 20 times by myself and share the result with you. Okay, so I played that lonely game by myself, and I got the following. The player 1 won 7 times, and player 2 won 13 times. Okay, so I wrote it here. Write this as proportion. How do you write proportion? You're going to do it how many times it happened over how many times the total thing happened, right? How many games did we play? We play 20 times, so it's out of 20. For player 1, it happened 7 times. For player 2, it happened 13 times. So that's how you're going to represent it. Notice that when you add 7 over 20 and 13 over 20, what do you have? What happened? You get 20 over 20, which is 1. So please note that probability add up to be 1. Very important property. Once again, when you add up all the probability, it always adds up to be 1. Which is a little different, right? Because when you think of probability, you always think of 100%, right? Add up to be 100%. In mathematically, we're just going to say everything add up to be 1. That means each probability is going to be between 0 and 1, right? Okay, very good. Number 3, who won more often? I'm not going to do it because we don't have it. We don't have a data. So, to determine the true probability of player 1 winning, we should list out all possible rolls that we could get. Use your table to find the probability of player 1 winning. Okay. Alright, well, so there's what happened? When you roll 2 dices, first side has 1, 2, 3, 4, 5, 6. Second side has 1, 2, 3, 4, 5, 6. So I just list all the possibility, right? For one of them, you have 6 of them. For second one, you have 6 of them. So let's list every single possibility. So for example, this right here will be 2 and 5. I'll leave it for here, 2 and 5 or 2 and 5. So I'm going to go fill it out. and then let's come back. Okay, so use your probability to find the probability of player 1 winning. When does player 1 win again? When the largest number is 1, 2, or 3, or 4. So I'm gonna 1 or 2 or 3 or 4. 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 Because that one's gonna be player 2, player 2, player 2, player 2. Right? Okay, so how many are there? Well, total there were 6 by 6. There are total 36 possibilities, right? So out of 36, how many makes player 1 win? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. So the probability of player 1 winning is 16 over 36, which is 4 over 9, which approximately is 0.42. Cool? Alright, which was closer to the probability you found on 4A? I don't know. Okay, so player 1 winning was 0.44. Did we guess that right? No, I was wrong. Actually, there's higher probability that player 2 is going to win. What would be the probability of player 2 winning? If the probability of player 1 winning is 9 over 4, what's the probability that 2 will win? It will be 1 minus 4 over 9, which is 5 over 9. Right? Because there's only 2 possible. Either 1 wins or 2 wins. If 1 win is 4 over 9, what will be the 2 win? 1 minus 4 over 9, which is 5 over 9. Cool? Cool. Alright. Our key things over here. These right here, what we did are the experimental probability. Meaning, we literally get the data by experimenting. Which, was that accurate? Was that what was supposed to happen? Not really, because it's just what we've experimented. What found over here is called the theoretical probability, meaning that's what should be happened by textbook wise. Like that's, but in real life, it doesn't really happen all the time like that, right? Like the probability of winning lottery is like 0.000001, which is really small, but does that mean that it'll never happen? No, it can happen. It's just really small. Okay? Alright, so let's go to the next page and write down the key points. Very important. Alright, we're going to write down a lot of information, so I need you to pay attention. Alright, there's going to be 3 key points. Alright. Important idea number 1 is probability. What is the probability? It is actually long-term frequency. Okay, so if it was a short term, that is actually unpredictable. We actually don't know what happened. But if it's a long term, things becomes a pattern. It's predictable, so we can find out what's going to happen. So over here, when we did the dice example, I bet if you were to play this game 1,000 times instead of 20, it would have been a lot more closer to the theoretical probability, right? Because the more you do, it's going to be closer to the textbook example. So that's what the probability is. Alright, so we also learned about theoretical probability. What is that? What we expect to happen in a textbook, right? Textbook example. That's how you can think about it. Or there's experimental probability, which means what actually happens. Cool? Alright, now key point number 2. Probability rules. I'm just going to write prob because I'm too lazy. Okay, so I'm going to write a little smart mathematical notation, which might scare you, but don't let it scare. Alright, so P of event A. Alright, so what does this mean? Folks, this is not P times event A. This is not a multiplication. The P represent probability of event A. So this is the probability of event A. How do you find the probability of event A? It's going to be the total number of outcomes goes to the denominator, and then number of ways A happens. That's how you find the probability of A. So over here, when you find the probability of player 1 winning, what was the total number of outcomes? There were 36 total number, so that went denominator. And how many cases that player 1 won? 4, 4, 4, 4. 16 goes on top, so 16 over 36, 4 over 9. That's how I find the probability. Alright, now, what about complement? Complement is not to praise someone, okay? In mathematical, complement is not that. Once again, complement is not that. So what is the probability of not event A? It will be 1 minus probability of event A. Does that make sense? Right? Because everything had up to be 1. So what will be the probability of A not happening? It will be 1 minus A. Now, what is the probability that A or B? A happens or B happens. It will be probability of A plus probability of B. It's like this. What's the probability of someone being a junior or being a senior? You're going to add probability of being a junior and add probability of someone being a senior. You just add it for now. For now. Because it'll get complicated next lesson. Alright, now what about probability at least 1? It'll be 1 minus probability of none. So probability at least one student comes to school. Then 1 minus probability no one comes to school. Oh, sorry, you guys didn't see the top. Alright, now key number 3. Probability models. You're going to list all possible outcomes. All probability are between 0 and 1. Remember that? I kind of highlighted on the previous page. Every probability is between 0 and 1. And when you add up all probability, they add up to be 1. Okay? Alright, let's check. Alright, what is your favorite color Skittle? Based on a large sample, here's a distribution color of Skittles that come in full-size font. Green, purple, orange. Ooh, we don't know the red, yellow. Notice all the probability is between 0 and 1, which is good. Alright, explain what probability of 0 to 14 for purple means in the setting. What does that mean? That means if you pick a Skittle many times, right? The probability is in the long term, you do it a lot, many times, we expect the proportion of Skittles that are purple will be 0.214. So let's write it down. If you pick a Skittle many times, because for probability we have to do it many times, we expect the proportion of Skittles, I can spell Skittle, that are purple to be 0.214. Excuse me. Alright, now how to find probability for red? Alright, probability for red will be what? Well, if it all add up to be 1, don't you just have to subtract 1 minus that, minus that, minus that, minus that? Yeah. So 1 minus 0.171, 0.214, 0.204, 0.214, oops, which set up to be 0.197. What is the probability that randomly selected Skittle? It's very important on a problem to say randomly, because if it's not, then probably wrong. We always have to select randomly. Skittle is going to be green or purple. It's asking about the probability. Okay, probability of green or purple. How do you find that? Well, over here, remember, probability of A or B is probability of A plus probability of B. So probability of green plus probability of purple. Let's go. How do you find it? Probability of green is 0.171, 0.214, 0.385. Is it good so far? Okay, very good. What is the probability a randomly selected Skittle is not yellow? Okay, so how do you do something that is not something? It's going to be 1 minus probability of something. So 1 minus probability of not yellow is yellow. That was easy. 1 minus probability of yellow is 0.214, which is 0.786. Cool. Alright, so we're done with the first page of 6.1. Good job.